Hello, let's talk about NADH and NADPH. Well, let's start a little bit general. So both of them are reduced electron carriers. NADH is produced actually from glycolysis and also in the citric acid cycle. As you see here, I have the pathway. So this is the glycolysis and this is the citric acid cycle. Also, we have NADPH. NADPH is produced in the pentose phosphate pathway and in the light reaction of plants. So there's kind of a little bit interesting about NADPH in the pentose phosphate pathway is that actually the essential product is not the pentoses, it's the NADPH, and explain later on why is that. So we had those both coenzymes, they undergo reversible reduction of the nicotinamide ring. In the next slide, we're gonna have the difference between the two of them. This is kind of like a little game. So let's start. The first one says primarily involved in catabolism. So you see the NADH and the NADPH, this actually goes in the NADH. Catabolism means the breaking down of big molecules to yield energy. So that's why NADH is primarily involved in catabolism. If we see the other side of the spectrum, we have primarily involved in anabolism. That's NADPH. If catabolism is the breaking down of big molecules to yield energy, anabolism is the opposite. Instead of breaking down, it's gonna build up big molecules. So you're gonna need energy to do that. And let's start with a process more familiar to NADH. As you can see here, I have these phrases like involved in oxidative phosphorylation and complex one. So yeah, NADH is involved in oxidative phosphorylation. By using the electrons from NADH, it's gonna be possible to to produce ATP. This is done by NADH donating its electron to the complex one, and by being transferred to different electron carriers and proteins, is gonna create a proton gradient that is gonna be used for the synthesis of ATP. So that's about NADH. Now let's talk a little bit more of NADPH. So NADPH is involved in anabolism. One of those cycles or processes, pathways is the Kelvin cycle. NADPH is required for the Kelvin cycle. Another important function of NADPH is related to the reactive oxygen species ROS. So we have it here. As I say, NADPH is the essential product of the pentose phosphate pathway. But why? So this is the reason why. NADPH has an essential role to reduce glutathione. And by reducing glutathione, it's possible to eliminate or to destroy the hydrogen peroxide and the hydroxyl free radicals. So that's why it's important. So by maintaining a reducing atmosphere, what this means? So you're gonna have more NADPH than NADP plus, and you will also have more reduced glutathione than oxidized glutathione. By doing this, the cells are gonna prevent the oxidative damage. Okay, the last part that I have of difference between the NADH and NADPH is related to the redox potential. Here I have the different redox potential, and this is accomplished by holding a ratio of the reduced form over the oxidized form. For NADPH, as I say, it's maintaining a reducing atmosphere. So it's gonna be relatively high for it. And for NADH is the opposite. It's gonna be relative low. So this is the difference between NADH and NADPH. I hope you like it. Thank you.